Hi all, welcome to the first part of the video lecture on ER model, that is Entity Relationship Model. So in the previous set of videos we gone through the basic terminologies that are related with the database management system, and we also saw that database design process, right? So from the mini world, once you get the requirements from the user, how you will come up with the backend design. So that is what we've seen so far. Now out of that, the most important phase is the very first phase, which is directly interacting with the user, that is a conceptual design, and this ER model is one of the popular model that is used for the conceptual design. So just let's recollect what we've seen so far. So initially we have this mini world, right? So mini world is what? The domain, right? So mini world is otherwise called as a domain, or you can call it as universe or universe of discourse, like that. So this is the area or something for which we are developing the database application, right? So the interested set of users are coming under the mini world. So it can be maybe a university, so for which you are trying to develop a university database for keeping information about the students, faculty, and other administrative kind of things. Or it can be an organization or a company where you will keep track of the employees, project, department related information, and many other things. So it can be anything. Now from the mini world, where the users are there, for which you are developing the database backend, right, you will collect the requirements, right? So the requirements collection and analysis you have to do. So after collecting the information requirement from the designer point of view, you have to analyze them, like which are all feasible to implement and all. So after doing this requirement collection and analysis, typically we will prepare something called a documentation, SRS documentation, software requirement specification document kind of thing. So this is not only for the backend design, for the design of any software we have in this particular phase. Okay, now once you have the a clarity on the requirements, like what you want to implement as the database backend, so the data requirements are with you. Now you can go for the conceptual design. So conceptual design, it is something like a plan for a building, right? I already told you this analogy. So you are going to construct something, so before that you are having a plan with you. So what is the purpose of this plan? So you can interact your with the customer, because this technical details or the technical jargons, those things the users are not interested, right? So from the user point of view, who are sitting at the mini world, so right, he is having very minimal technical knowledge. So it is always easy for the user to look at the plan, right? So when we are having this plan, it's easy, like what are all the requirement you want, accordingly you can cooperate, and once this plan is finalized, you can go for the actual design of the building. Okay, so typically something like that. So same analog, it's analogy only. Okay, now from the user you are communicating, and you are pictorially you are trying to represent it in a very user friendly manner. So that is a conceptual design phase, and after that we will get something called a conceptual schema, which is a high level data model, and this ER model is such a model. Okay, yes, so once the conceptual schema is prepared, or the high level data model is prepared, you can give that to the user, and so that he can see it and he can say the modification if any. And once it is finalized and the user accepted the ER model or the high level data model, you can go for the logical design. Okay, so logical design, so typically we have something called a logical schema, and one such logical schema is something called DBMS, relational database model. Okay, so relational model, let me write like that, relational model, and we will see. So in the second module completely we are exploring this relational model, and after that we will go for the actual physical design where the internal schema will come. So it's just like it's dealing with in the particular hard disk, or where you are storing the data, exactly how you will organize the data, what kind of indexing is to be used, right? So that kind of things are coming here. Okay, so that is very much related to the particular hardware which we are having. And you can see that this relational model is also something, this whether it is relational model or schema model, that is something platform dependent, right? So I can say like that, or it is more specific to the DBMS. So this part, so this logical design is coming in between. So if you can see this after understanding relational model, you will understand that it's related to the actual implementation, as well as it is something not far away from the user, right? So user can even understand this, so he can even can contribute something by looking at this. Somewhat technical, but still it's not that much user friendly like ER model, but still it is somewhat near to the user view, and also it is very close to the implementation view. So it will act as a something between. So that is why this dot is shown like this. So below that what we have is the DBMS specific things, right? And above that we have things which are independent of the DBMS. So that is very important. The CR model is a purely database management system independent model. So whether you are using so there are many DBMS softwares available in market, like IBM is having its own DBMS software, Oracle DBMS software, SQL, MySQL, so like that many variations are there. So all of them are using the common ER model, right? So ER model is something that is independent of the database management system software you are using. But the other things, relational model indexing, they are more closely to DBMS which you are using. So sometimes if you are changing the database management system to something like not only SQL, NoSQL and all, and accordingly that relational model is not at all be suitable there. So there you have to go for something different. Out of that, this relational model is something commonly used for many of the DBMS softwares are okay with the relational model, but still it is specific to the DBMS which we are using. Okay, hope you get an idea. And parallelly you can see that, so this is something purely the data related things, right? So what functionality you are going to do with the data, that also you can mention, right? So if it is a student database, you want to report the grades of the students, or you want to have an application which will collect fee from the students, and also it will give a message to the students what kind of fee it is, like if the fee is pending. So like that many functionality you want to achieve with the data, right? So here it is purely data requirement we are collecting, and parallelly we can collect the functionality requirement, right? So then you will do something like a functional analysis, and so typically if using this function you are actually dealing with the database, right? So where we are using something called a transaction. So transaction is basically some kind of application program function that will try to access the data in the database. So it can be a read access or a write access, like this. That is the basic definition. So this terminology we will use. So high level transaction specification we have, and then we will go for the application program design. So in the sense using some high level language like Java or something, we will design the function, and we will keep on interacting with the logical schema, right? So on backend, like the final transaction implementation will be dealing with the actual internal schema. So something like that. So anyway, we are actually in this subject we are focusing this backend design part only, and definitely in your next semester you are having system software lab, not that I think DBMS lab is there, and that time first you will go through all those things, and then finally you will develop an application based on this DBMS. I mean you will be using both the front end and back end, and that time you will get a feel of this, right? How this is happening. Anyway, in our course also we will cover something, but mainly our focus is this. Okay, so right now we are at this level, that is we are going to focus in detail on the ER model. So ER model means the entity relationship model, and you know what is entity, what is relationship. So those things we given an overview in the previous set of videos, but here we will see them in detail, right? The exact mathematical meaning we will see. So entity relation model is a popular high level conceptual data model. So it's a high level in the sense it's using which you are interacting with the user for the conceptual data modeling. So this model and its variations are frequently used in the conceptual design of most of the database application, and you can see that it is DBMS independent. Okay, and many database design tools employ its concepts. So that shows the relevance of this topic. And there is something called as ER diagram, which is a pictorial or the diagrammatic notation of the ER model. We will see that. So finally, in this set of videos, what you have to do, so from the university point of view, there will be a question. So they will give a set of specification or requirements of some kind of mini world, and you have to come up with the ER diagram. So that is the final outcome you are supposed to do. So systematically we will develop the concept how to draw this ER diagram. Okay, so that is what we are going to see. And there is something called EER model, that is enhanced ER model. Anyways, in your syllabus they are not mentioning enhanced ER model, so they are talking about only ER model, so that we will be covering. And those who are interested in that Navate textbook itself, this is given as a separate chapter and you can go through it, because when it comes to the application development, so this will be useful for you, but from the course point of view we will not be covering this. Okay, so this is basically an extension to the ER model. After studying ER model, if you are going through this, you will get it. And there are many concepts, nice concepts like specialization, generalization, inheritance. These things are further added into this union data type, etc., are added into ER model, and that makes the enhanced ER model. Okay, so there is other than ER model, is there any other modeling technique by which you can do this conceptual design? This UML also you can use. So nowadays people are trying this UML model, but this ER model is something very popular and it is used for most of the application. But UML modeling is also an option, which is an object modeling methodology. It's becoming increasingly popular, and this, you know, this DML model we will use for the normal software development. And here in database, by treating database as a software, for having the database design process also, you can use this unified modeling language as a conceptual model. And this method will go beyond the database design to specify detailed design of the software. And okay, so it's something look like class diagrams. Anyway, you don't have to worry about this. What I was trying to say so our intention is to focus on this ER model, so we are supposed to know this in detail. Okay, so that's all that I just mentioned only. So some other ways of doing the conceptual design. Now, so this is a very important example. So I am purely preparing this PPTs, my lectures, everything based on that Navate textbook, El Masri Navate textbook. And in that textbook, if you are seeing, if you are trying to read, they are taking this as a basic example, and all the concepts of ER model they are explaining with respect to this example. And finally they are drawing, they taking some other case studies, and they are trying to draw that ER diagram and all. But initially, for developing the concept, this example is taken. So whatever things I am telling, it's a very simple thing. Some explanation of a mini world is what we are going to see, that you have to keep in your mind, because later on this will come again and again in my further videos. In that time you should have a clarity on the things. So just understand the company database. So it's very easy, right? So I have a organization or a company for which I have to develop a database model. So that is my intention. So what are all the things that is coming into your mind? Like, so definitely in an organization, employees will be there. So I need a database for keeping details of the employees, right? So that is one thing. So I'm not reading these things, I'm just asking you. So mostly if I'm saying about a company, people will be talking about the employees, right, working on the company. So we have to keep their details, like name of the employee, their age, their address, maybe their salary details. Many things you can keep in that employee database. Now but I can tell another thing is you have to keep information about different departments of the company, right? In the sense, if it is having right, okay, so maybe some research and development wing will be there, some other wings are also there. Okay, so that you can think about how HR, human resource, HR department, like that many department you can think about, and the details are also we need. And there will be the managers for the department, they are again employees, but still we want to know which employee is acting as a manager for a department. So like that many details you can keep. Okay, so now what else? Employee is there, department is there, and typically as it is a organization company, they will be running different projects, right? So these projects may be part of I mean different departments are offering different types of projects, and the employees are supposed to work on the projects, right? And so you have to keep details about the project, project name, which department is holding this project, like that many other things you have to keep. And one more thing I can tell is the information about the dependents, because you know in most of the organization this insurance kind of things are there, so you have to keep the details of your dependents, right? So if something happens to you, like who can claim the accidental insurance and all, so there will be a set of dependents, like maybe the spouse, kids, parents, like that. Okay, so that information also we have to keep in a separate data. So this is a minimal thing, but in actual implementation you can think about a number of databases, but minimally we need this many things. Okay, So this kind of an example is what we are taken, and from where you are getting this much detail, right? You have to interact with the user, right? During the requirement collection phase, you will be interviewing the user, or you can have some other kind of group discussion, etc., and by which you will collect the details. So the company database keep track of the company's employees details, the department details, and project, and also this dependence also. Suppose that after the requirement collection and analysis phase, the database designer provide the following description of the mini word. So the final description of the mini word. So in your university exam also you can expect so it's almost 99% expected question, some mini word description they will be giving, and from that you have to come up with the ER diagram, final ER diagram you have to draw it. So definitely it will be there. So give that importance to this topic. So the part of the company that will be represented in the database. The first point is the company is organized into different department, right? So each department has a name, unique name. There is a unique department number, some kind of ID, identifier, and a particular employee who manages a department. So minimum things only we are discussing here. You can think about many other things also. Accordingly your database will vary, right? The fields will vary, that's all. Now we keep track of the start date when that employee began managing the department. So there will be a number of managers for the same department. For each manager, what is his start date? From this point onwards he is a manager. So like that you can keep. Now another one, what about the location where this department is located? Sometimes the same department is located at multiple locations also. Maybe it's branches and all, okay. Now the second thing is a department controls a number of projects. You have to keep track of the project information, each of which has a unique name of the project, and there will be a unique project number, some kind of identifier, and typically this project is specifically for a particular location, otherwise it is slightly meaningless. That also you can spread across multiple locations, it's not a big deal, but mainly as per the requirement. So see, these things are actually given to you, so you don't have to worry about why it is in single location or why not multi-location. Those things you don't have to worry. So once you have this set of specification, how to draw the diagram, so that is your target, okay. So it's given in the question like the project is supposed to run in a single location, but department can be of in different, more than one location, okay. These are all the specification given to you already, right? Now the third thing is the database will store each employee's details, like the employee name, some kind of identifier, SSN, social security number, typically we refer like this, some kind of ID, okay, some address, salary, sex, gender, and the birth date. An employee is assigned to one department. So see, these are all the constraints that we collected from the mini world. You are not supposed to change it. Accordingly, you have to develop your database. Okay. So here your intention is to develop the ER diagram. Okay. An employee is assigned to only one department. So that is the he can work on multiple departments, that is fine, maybe on different projects, but basically he belongs to a single department. So that is the thing. But may work on several projects which are not necessarily controlled by the same department. Okay, fine. Now the second thing, it is required to keep track of the current number of hours. So how many hours per week that an employee works on a given project. So okay, so for an employee working on a project, you have to keep track of, like accordingly maybe we may be fixing his remuneration and all, right? So how many hours he worked on the particular project in a week. So that also we will keep, as well as the direct. One more thing, who is the direct supervisor of that particular employee? So every employee will be under the control of another employee, right? So the supervisor of him, who is that? That also you have to keep. Okay, that is another employee. The database will keep track of the this is the last thing I told you, like dependent information of each employee for insurance purposes, including each employee's dependent's first name, gender, birth date, and relationship to the employee, whether he is a spouse or a kid or what kind of relation that dependent is possessing with the employee. So that about it. So keep this example in your mind. So we are talking about something called the company database, where we have a some kind of entity for the department, another entity for entity in the sense that database typically in ER diagram we represent like an entity. Okay, there is an entity for employee, there is an entity for the project database and dependent. So like that 4 things we discussed, and some of the constraints also we saw. Anyway, this will come again and again, so we will call this same example. Okay, so keep this in mind. So this is a final diagram you are supposed to draw, so don't worry about this diagram at this point. So I just shown you like this is our goal, final goal. We are supposed to draw a diagram like this by looking at this specification of the mini world. So mini world specification is what you are having with you now, and from that you have to come up with a diagram like this. Now how to draw this diagram we will explore systematically. So simply something you will understand, like there is an employee entity, and these are all the fields of the employee, like SSN, birth date, name itself, first name, middle name, last name. It's a very simple thing actually. Address, salary, sex, like that information. And there is department is another one, department name, department number, location. But dependent project, like that, how they are related, like employee manages a department. So who is manager of this particular? So employee, sometimes the employee will work for a department, also some employees will manage a department. So these are all different relationship between this employee entity and department entity, and the employee will work on a particular project, right, or set of project. And employee is having dependent, like the depends of this set of people dependent on this employee, right? So like that. An employee supervises another employee. So like that, different relationship you can think of, and they are connected. Sometimes we are having this double line, single line, dotted circle, and oval shape itself, double line, some underline is given. So we are going to see the meaning of all those things, and numbers are given like N1, right? So it's a very simple thing in the entire course. Okay, so just focus on the meaning of all those things that I will explain in the upcoming video lectures, and finally you will be able to draw something like this. So same thing, given any specification of any kind of mini world, so don't expect the same company database they are going to they can give you some university database design kind of question, or something random they can give you, and that time you should be able to draw something like this. And how to draw is what we are going to see, and we will develop like what is entity, what is relationship, right? And what about the attribute, what are all different types of attribute, and how these things are related, what are all the constraints. So like that the topic will be proceeding. Yes, thank you.